Minasan, konnichiwa. Hello and welcome to this Intel One API rendering toolkit briefing. I'm Neel Dhamdhere, Strategic Business Development Manager, Software Development Products within Intel Architecture Graphics and Software Division supporting Japan market. In this presentation, we will cover what's Intel's strategy to deliver high-performance rendering solutions. What software tools does Intel provide to help content creators and developers to bring their ideas to reality with performance, efficiency, and flexibility? And also, how Intel's rendering solutions are benefiting our customers. There's a worldwide data explosion, and rendering is widely used in motion picture animation, medical imaging, weather prediction, manufacturing, retail, autonomous cars, scientific computing, and gaming. However, rendering is getting more complex, requiring more compute and more memory to support high resolution of multiple objects. As you can see on the right, this single image of a stellar radiation rendering is over 2 terabytes, and in video it takes over 3000 time steps to render correctly. So delivering true to life visualization requires tremendous computing power along with advanced rendering, ray tracing, and rasterization developer tools. There are two major rendering techniques in use. Basically, rasterization on the left hand side displays a 3D object on a 2D screen. Rasterization is based on triangle mesh and texturing, most commonly used in gaming today and largely optimized by GPUs. Ray tracing, on the other hand, as you can see on the right hand side, is a much more richer image, is much more computationally intensive technique that models the physics of light to generate realistic images, and it's increasingly used in animation films, scientific computing, manufacturing, gaming, etc. So what approach does Intel take in rendering? Intel takes a platform approach to rendering, which helps developers optimize rendering applications on existing hardware, utilizing advanced technologies such as AVX512 on Intel Xeon and Core processors, Intel Optane memory, and emerging Intel XPU platforms such as Intel Xe architecture GPUs. oneAPI is an open specification cross-architecture programming model that provides freedom from the technical and economic burdens of proprietary models. The Intel implementation of oneAPI, which is basically the Intel oneAPI toolkits, help developers build high-performance cross-architecture applications that bring out the full value of Intel XPUs, that is CPUs, GPUs, and FPGAs today. The rendering toolkit is part of the oneAPI toolkits, which is enabling state-of-the-art ray tracing platform capabilities from the edge all the way to the cloud across a full range of XPUs and networking hardware. So Intel Optane Data Center Persistent Memory is game-changing Intel rendering platform ingredients. That's because it enables storing and processing terabytes of high fidelity imagery data closer to the CPU with memory-like performance and with the storage and capacity benefits of NAND. So for example, the Intel persistent memory performs at latencies near LPDDR4 DRAM. So the effect is that it enables processing of huge amounts of data. It's up to 3 terabytes per socket can be configured without having to move the processing data of the compute nodes. So this enables our customers to process large amount of data at the right price point and with the right performance. On the software side, one of the key advantages of oneAPI is that frameworks built on oneAPI can be portable across vastly different architectures. For example, FFmpeg is a popular open source framework used for video processing. Within FFmpeg, a media plugin is used to interface with different devices. By utilizing one VPL video processing library within oneAPI allows for FFmpeg to provide accelerated support across CPU and GPU. So the application using FFmpeg need not worry about how that's handled underneath in a seamless manner. Similarly, as we will see, rendering application developers can also utilize rendering toolkit libraries to bring their ideas to reality with performance, efficiency, and flexibility. Intel oneAPI rendering toolkit consists of a set of open source libraries used in both professional and scientific rendering, helping developers get the best performance out of their ray tracing applications. These libraries are optimized for Intel XPUs with support for features such as SSE, that's the streaming SIMD extensions, AVX, AVX2, and AVX512 instructions. Libraries are released under the permissive Apache license 2.0. So with that, let's take a closer look at the libraries. Embry is our core ray tracing library that provides hyper-realistic rendering. Hollywood movies have been made using Embry. In fact, Embry received an Oscar Award for Technical Achievement in 2021. The Embry library provides a wide breadth of high-performance kernels across many geometries and surface types used in rendering. So basically, customers get performance-optimized ray tracing kernels supporting ray tracing algorithms optimized for Intel CPUs. Embry requires at least an x86 CPU with support for SSE2 or an Apple M1 CPU. Using the Intel compiler improves performance by approximately 10%, and performance also varies across different operating systems, with Linux performing typically the best. A quick note about Embry before we move on is that Embry is a part of Intel oneAPI today, but please note that it has been around since 2014 and has been continuously improved with customer feedback. OpenVKL or Open Volume Kernel Library focuses on high fidelity ray tracing for volumes such as cloud, grass, and hair. The volumetric data processing algorithms are optimized for Intel platforms. So you get a dedicated APIs to interface with a variety of applications needing volume rendering. OpenVKL provides a C API and also supports applications written with the Intel SPDM program compiler by also providing an ISPC interface to the core volume algorithms. This makes it possible to write a renderer in ISPC that automatically vectorizes and leverages SSE, AVX, AVX2, and AVX512 instructions. ISPC also supports runtime code selection. Thus, ISPC will select the best code path for your application. OpenImage Denoise is an AI-optimized denoiser for ray tracing, providing visually stunning denoised images. The OpenImage Denoise library ships with a set of pre-trained filter models. It's not mandatory to use these, but to optimize a filter for a specific renderer, sample count, content type, or a scene, it's possible to train the model using the included training toolkit and user-provided image dataset. The Intel OpenImage Denoise supports Intel 64-bit architecture as well as compatible CPUs from Apple and runs on anything from laptops to workstations to compute nodes in the HPC systems. Intel OpenDenoise internally builds on top of the oneAPI Deep Neural Network Library, the oneDNN, and automatically exploits modern instruction sets like Intel SSE4, which is the streaming SIMD extensions, AVX2, AVX512, to achieve high denoising performance. A CPU with support for at least SSE 4.1 or Apple Silicon is required to run Intel Open Image Denoise. Osprey provides an easy-to-use API for ray tracing, path tracing, and volume rendering for Intel CPUs. This library is completely CPU-based and runs from anything from laptops to workstations to compute nodes in HPC systems. So if there's a single CPU or if it's a cluster with MPI, Intel Osprey can run, and it can also enable advanced shading effects, so image shadows and transparencies can be rendered interactively, which enables new insights into huge data sets. Large scale data is not a problem. If it fits in memory, we can render it, and we are seeing routinely that there are data sets in hundreds of gigabytes that Osprey is able to render. Besides Osprey, we also have Intel Osprey Studio and Hydra. It's a scene graph application used to develop ray-traced interactive real-time rendering tools. So the Osprey and both Osprey Hydra, they actually connect the rendering toolkit libraries to USD, which is the Universal Scene Description, which was developed by Pixar Studios for use in visual effects and animation, but it is starting to get traction in other industries as well. So the Osprey Studio and Osprey Hydra, we are seeing increasing use in the developer community as well. And finally, we have Open Software Rasterizer, or OpenSWIRE, which provides a high-performance OpenGL-based low-level rasterization library for CPU rendering. So OpenGL is simply an interface that defines a set of standards of functions needed for drawing 3D graphics. So OpenSWIRE uses Mesa, which is basically a specific type of OpenGL. So now that we have seen what the rendering toolkits consists of, let's also see how Intel helps our customers deliver cost-effective performance across a wide range of use cases. oneAPI rendering toolkit is increasingly used in studio animation, films, in scientific computing, so things like simulations, weather predictions, space exploration, 3D design, and manufacturing, gaming, and virtual experiences. Some of these use cases will be covered in detail in the next section, but let me touch on a few examples of how rendering toolkit is being used in HPC. HPC renderers increasingly use the Intel rendering toolkit libraries in HPC and scientific visual computing. This is an example of rendering toolkit being used in scientific computing. Some customers include the Intel rendering toolkit libraries in their own in-house renderers. And we're also seeing a lot of customers using applications that directly call the Intel rendering toolkit libraries to accelerate ray tracing performance. As you know, in exascale computing and HPC, there is a growing gap between I/O bandwidth and flops. As a result, the majority of simulation data may be lost. In this example, the Stephen Hawking Space Center needs to render huge simulations to understand the most extreme phenomena in the universe. They use the Intel oneAPI rendering toolkit to process huge amounts of observational data to simulate and visualize that data in real time. Another example is seen in the Frontera, which is the world's largest academic supercomputer. They're using the Intel platform approach quite well. So they use Xeon, they use Octane memory, and also rendering toolkit to preserve the huge amount of generated simulation data in situ. So by in situ, we mean that the libraries such as Embry and Osprey, they can render the data without having to move the data off the compute node. So by doing this, they're able to preserve the simulations and maximize the use of their system. Our competitors support powerful GPUs with built-in hardware ray tracing and AI denoising. So how does the Intel oneAPI rendering toolkit compete? I would like to highlight three main advantages. First is memory. Even the most expensive graphics cards are limited to 12 gigabytes to 48 gigabytes of local memory. With Intel Optane Data Center Persistent Memory, we can provide large memory capacity of up to 3 terabytes per socket at significantly lower cost than DRAM. Second is third-party support. oneAPI rendering toolkit is based on open source libraries and used by a broad range of third-party applications. And finally, also please note that Intel oneAPI rendering toolkit libraries used in these applications will extend to Intel's full XPU platform, which is the current and future CPUs, GPUs, FPGAs, and accelerators. So what about application support? Currently, there is more than 100 applications optimized by Intel oneAPI rendering toolkits across studio animation, films, HPC, scientific, visual computing, simulations, weather prediction, space exploration, 3D design, manufacturing, gaming, and virtual experiences. Here are some examples of ISVs and users in professional rendering, engineering, scientific markets, which are currently using the Intel oneAPI rendering toolkit. Intel is deeply committed to delivering a solution based on open source, industry standards, flexibility, and choice. We participate and support open source and industry standard forums. Intel oneAPI rendering toolkit is offered together with the foundational Intel oneAPI base toolkit, which includes a core set of tools and libraries to build and deploy data-centric applications across architectures. It features the Datapile C++ language, as well as the domain-specific libraries and enhanced profiling, design, and debug tools. The Intel oneAPI rendering toolkit, as you have seen, gives you these 5 powerful rendering and ray tracing libraries for creating photorealistic visuals. As a first step, we recommend test driving the Intel oneAPI rendering toolkit in the Intel Dev Cloud, where you can evaluate the workloads on the latest Intel hardware. So you have free access, there is no installation, there is no setup and no configuration required. You can just run your workloads on the target Intel hardware within the Intel Dev Cloud. I hope you got a good overview of the Intel oneAPI rendering toolkit today. There are also several online resources that I'd like to recommend where you can get further information and details. Also, at any time, if you need more specific information about the rendering toolkit or any other toolkit in the oneAPI family, please feel free to contact Intel or Excelsoft. With that, I'd like to hand over to Excelsoft Kubotera-san to explain further details.